Okay, in this video lesson, we're going to take a closer look at the unit circle. Up to this point, this is what we've created with our unit circle. So now what we're going to do is try to implement a little bit of trigonometry into our unit circle. So we'll first start with our first trig function, sine. And so we'll look at the sine of all of the angles represented in the unit circle. So what I'll first do is we'll pull up the calculator. First thing I want to do is make sure it's in degrees, because that's what we're working with. And we'll go through the different sines of all of the different angles that are used in our unit circle. So the first one was sine of 0. We get 0. Sine of 30 degrees was the next one, which is 1/2. Sine of 45 was our next one. Radical 2/2. So some of these numbers are starting to look familiar. Sine 60 degrees. Radical 3/2. Again, another familiar number from our unit circle. 90 degrees. 1. Sine next would have been 120. Radical 3/2. Again, next one would have been, what's that, 135? Oops, let's do sine first. Sine 135. Back to the radical 2/2. Sec 35, 45, 50. 150. I keep doing this. Sine of 150. Back to 1/2. Sine of 180. 0. 80, what's that, 210? Sine of 210. Back to, now negative 1/2. That's interesting. 210. Where we at? Sine 215. Now what's that? 1525. Negative radical 2/2. So again, similar numbers. 25, 35, 40. What's that? 240. Sine 240. Negative radical 3/2. Again, similar numbers. Sine 270. Negative 1. All right. Sine, what's that? 300. Again, similar number, radical 3/2, but this time negative. Almost there. Sine, what's that? 3. Where we at? 30. Sine 315. Again, radical 2/2. Sine 315. What's that? 330. Negative 1/2. And sine of 360. So we went through all of the angle amounts. So let's go ahead and see how that compares to our unit circle. So these were all the different values we got as we went to the calculator and found the sine of all of different angles that's represented in the unit circle. But now let's take a closer look at all of these values. If I look a little closer, all of these values are actually represented in the y coordinates. So they're all around the circle here. So if we took 60 degrees, so a 60-degree angle, the y coordinate happens to be radical 3/2. And look at that. Sine of 60 from the calculator was radical 3/2. If I took 210 degrees, the y coordinate, negative 1/2, because we're in quadrant 3. Sine of 210, negative 1/2. Or if we look at 360 degrees, the y coordinate was 0, and sine of 360 was 0. So we can conclude that the y coordinate at any of these angles that are represented in the unit circle, the y coordinate represents the sine of that angle. So we're beginning to see the usefulness of the unit circle. So let's transition now to cosine. So I'll go back to my calculator. We'll go here. Let's use this one. There we go. Clear. And we'll go through cosine. So cosine 0, 1. Cosine 30 degrees. There's our radical 3/2. Cosine, what's that? 45 degrees. Radical 2/2. Again, similar numbers. Cosine 60, 1/2. Cosine 90, 0. cosine 120. Negative 1/2. So again, similar numbers. Cosine was that 135. Negative radical 2 over 2. Cosine 35, 45, 50. 150. Negative radical 3 over 2. Cosine 180. That should be our negative 1. Cosine 210. Negative radical 3 over 2. Cosine, what's that, 25. Cosine 225. Again, similar values. Cosine 225, 35, 40. What's that, 240. Negative 1/2. Cosine 270. Back to 0. Cosine 300. Almost there. Back to 1/2. Cosine 315. Again, these are all the values represented in the unit circle. Radical 2 over 2. Cosine was that 15, 25, 30, 330. Radical 3 over 2. And cosine 360. Back to 1. So, when we go back to the PowerPoint and we demonstrate, or at least reflect all of the values we just saw in the calculator, from positive 1 all the way back to positive 1 at 360 degrees. Upon closer look, all of these values are actually just the x coordinates. And I would presume you started to perceive that that was chances what was going to happen. So if we look at, say, 90 degrees, at the 90-degree angle, the x coordinate happened to be 0, and cosine of 90 is 0. If I looked at 150 degrees, there's my angle, the x coordinate, negative radical 3 over 2, cosine 150, negative radical 3 over 2. One more. At 315 degrees, when I create the angle, the x coordinate happened to be radical 2 over 2. There we go, cosine 315, radical 2 over 2. Before I go a little further, just want to mark, this is where you want to be careful. Because if you look at the 315, it appears to match with this ordered pair. This is why I drew the actual angle. 315 is the line in between these two. This is the 330. There's the 315. I'm sorry, this was the 300. 315 is in the middle. So by drawing this, it helps me to see that it's the middle ordered pair that I'm working with. So be careful when you begin to apply this strategy. So what we conclude from this screen is that the x coordinate at any angle represents the cosine of that angle. Now, up to this point, all I spoke about was degrees. But we should be able to acknowledge and transfer this information that if the angle had been in radians, we would have still, for sine of any one of the angles at radians, would have still been the y coordinate, and cosine is still the x coordinate. So this is not unique to degrees. It's transferable to both degrees and radians. Let me illustrate. I'm going to work with 7 pi over 6. Now go back to this one, but now I'm going to change my mode to radians. All right, and now we'll do the sine. I'll put the fraction first. 7 pi over 6. There we go. Negative 1/2. Let's do the cosine. Cosine of 7 pi over 6. There's the negative radical 3 over 2. So negative 1/2 was the y coordinate at 7 pi over 6, and negative radical 3 over 2 was the x coordinate at 7 pi over 6. Let's see, there's our 7 pi over 6, and there are the two coordinates. So, in conclusion, what we conclude here, once we give a closer look to the unit circle, says in the unit circle. So only when we're working with the unit circle, the x coordinate at any angle, whether it be degrees or radian, represents the cosine, And in the unit circle, the y-coordinate at any angle represents the sine. Okie dokie.